Question 7. What is sometimes done to compensate for fluctuations in instrumental sensitivity? Describe the process, not just the name. So, instrumental sensitivity is the signal divided by the concentration. So, many instruments have quite a number of steps between the generation of a signal and the introduction of a sample. So, for example, in a HPLC or a GC, another chromatographic method, there's a certain amount of sample is injected into a flowing stream, and that stream is then detected. The analyte in that stream is then detected. So, in this case, sometimes the injection volume can vary a little bit. Let's say you repeated an injection 3 or 4 times, and because of there was a little bubble in the first one, and then the second one didn't plunge all the way down, or the injector stuck a little bit, and so there can be, for the nominally the same injection, there can be a range of signals that the same analyte concentration can give. So when one is working with an unknown, one can put in an internal standard. And so that, in fact, is the name of what we're talking about. So internal standards are chemicals, like another element, if it's an elemental analysis that you might do by ICP, or it could be another organic molecule like benzoic acid if you're doing an HPLC. That is present in all of the samples and standards in the same concentration, for example. And the presence of this internal standard is important because because it's in the same concentration, you can expect the same signal for it in all cases. So if the signal dips or the signal bumps up a little bit, you can expect the analyte signals to be modulated by the same amount, to be affected in the same way, right? So internal standard has to behave pretty much like your analyte does in the instrument, and it has to be measurable in the sample, resolved from the analyte and any other possible interference. So in short, an internal standard is a fully resolved analyte measurable alongside the sample, which is the amplitude of which is expected to be constant. So, instrument sensitivity fluctuations are compensated by dividing the analyte signal by the internal standard signal.